So triangles have their own vocabulary, and I think it's important that you memorize the meaning of each of these words and know how to interpret them, because a lot of times a question will just say it's an equilateral triangle or it's an isosceles triangle, and they won't go into the definition. They expect you to know that definition. So if we look at these words, let's start at the top. So we know triangles are three-sided shapes. And if all three sides are identical in length, then that would be an equilateral triangle. And it's important to know that within a triangle, I'm just drawing a non-equilateral now, if this is the largest angle, this will be the largest side. Because if you imagine rotating this angle and making it even wider, then this side would get stretched even further. So the bigger the angle gets, the bigger this side gets. And in an equilateral triangle, all the sides are the same length, which means that all the angles are the same length. So within any triangle, within that single triangle, the sides are relative in length to the angle that they are across from. And if you have trouble recognizing which angle it's across from, it's the angle that does not touch that side. So this angle touches this side and this side, which means it's across from this side. Moving on to isosceles. Isosceles means at least two sides are equal in length, which means at least two angles are equal in length. Now, an equilateral triangle is a version of an isosceles triangle because an equilateral triangle does have at least two equal sides. But isosceles triangles can also be triangles like this, where this side is equal in length to this side, but this side is of different length. And in this situation, this angle, which touches this side and this side, is opposite from this side, and this angle, which touches this side and this side, is opposite from this side. So these two angles are going to be the same. And then this angle here will be 180 degrees minus the 2x, because it's whatever would complete 180 degrees as the sum of all the interior angles. So that is an isosceles triangle. Now, a right triangle is probably the most famous type of triangle, and a right triangle has a 90-degree angle. So it's possible it could be isosceles. This isn't telling us anything about these two angles. These two angles could still be equivalent, but it's telling us that one of the angles has a 90-degree angle. And right triangles are important because they follow special rules. And so we're going to talk about special right triangles in another video. But one of the special rules that they follow is called Pythagorean theorem. And Pythagorean theorem says that if we have a right triangle, the two sides that are attached to the right angle itself will always add up when squared to the length of the hypotenuse or side opposite the right angle when that side is squared. And this is a squared plus b squared equals c squared. And it's just a unique property of Pythagorean theorem, of right triangles, which we call Pythagorean theorem. So, for example, one special type of right triangle that we'll talk about later is a 3, 4, 5 right triangle. And if you see any triangle, even if they draw it so it doesn't look like a right triangle, if a triangle has sides of 3, 4, and 5, it has to be a right triangle, because any triangle that follows Pythagorean theorem has to be a right triangle. So it goes in reverse as well. If you know that the sides are in a ratio that follows Pythagorean theorem, then you know that triangle has a right angle. And the right angle will always be across from the biggest side, because the right angle will always have to be the largest angle in the triangle, and all sides are relative to angles. So in a 3, 4, 5, a squared would be 9, and b squared would be 16, and c squared would be 25. And 9 plus 16 does equal 25, which means that a 3, 4, 5 triangle is a right triangle. It doesn't tell us anything about what these two angles are, but we know this angle is a right angle. All right, now moving on to obtuse. Obtuse triangles are triangles that have one angle that's larger than 90 degrees. So this might be an example of an obtuse triangle where this angle is greater than 90 degrees. And that means that one of the sides is going to be very long, and these other two sides will add up to something less than 90 degrees, since they have to complete the triangle. Now, when you're trying to find the area of an obtuse triangle, and we will cover this in another video, but if you're trying to find the area of an obtuse triangle, it can be a little bit tricky. And basically the trick that you can use is to extend an imaginary line from the base and then drop down an imaginary line from the highest point on the triangle, which is going to be hanging off the side like this most often, and then use that to create an imaginary right triangle where the height of this imaginary right triangle is the height of your obtuse triangle, and the base is this base here, the original base, not the extended base. So we'll cover that in another video, but just something to touch on because it's a good thing to see a couple of times. An acute triangle is a triangle where none of the sides are greater than 90 degrees. So a classic example of an acute triangle would be an equilateral where all the angles are 60 degrees since they have to be the same size and they have to add up to 180. But an acute triangle could have like an 89 degree angle and then two other angles that were also less than 90 degrees. And in an acute triangle, when we try to find area, typically what we do is we drop down an imaginary line from the highest point, which is usually inside the triangle, and that will create again an imaginary right triangle on either side of that line, like this side. And then the base of the acute triangle is just the base of the triangle that lies perpendicular to that line that we just dropped down. Now the third side rule is an important rule, and it gets tested a decent amount. So it's important to know this rule. And this rule states that in a triangle, the longest side has to be shorter than the addition of the other two sides. Longest side is less than two other sides combined. And so if we visualize this, what that looks like is if we have a triangle with two sides that are 2 and 3. So say this side is 3 and this side is 2. Well, if we lie them next to each other so that they're parallel to each other, they would extend a distance of, I'll use two different colors here, they'll extend a distance of 5 total units. And if they extend a distance of 5 total units, then to touch the tips of these together, I would extend a line of distance 5. But if I extend a straight line from end to end, all I'm doing is creating basically like a smushed together straight line. That's not a triangle. It doesn't have any actual angles in it. So I would need to put a slight bend in these two angles, or in these two sides, so that I could then attach their ends and make it an actual triangle. Now, in bending them towards each other, I'm moving the tips of these sides towards each other, which means that this line here connecting them is getting shorter. So the longest side always has to be shorter than the addition of the two other sides, because if it were longer than the addition of the two other sides, it would be impossible to connect the sides. For example, if I had a side of 10 and a side of 3 and a side of 2, I could never get these two sides to meet each other. But if it's exactly the same length, it would create a flat line. And so it has to be smaller than the addition of the other two sides, and that's the principle behind the third side rule. So if I gave you sides of, let's say, 3 and 5, and I asked what was the potential value of the other side, well, the 5 could be the largest side, in which case the remaining side would have to be greater than 2. But the new side could actually be the longest side as well, and that new side cannot be longer than the addition of these two sides, so it has to be less than 8. So the new side could be anywhere from 2 to 8 in order to keep this a real triangle where the sides do not break the rule that we set out initially.